Up, amazing people, students, lovers of chemistry out there. I'm super excited to be here with you on this video. It happens to be an episode in this topic of stoichiometry that we've been dealing with thus far. And on today's video, we're going to be handling stoichiometry with chemical equations. If you're stumbling on this channel for the first time, my name is David and I'm an online chemistry tutor for high school kids. I'd like you to sit back, relax and enjoy every bit of what I've got for you in today's video. So let's see if we can learn a thing or two. At this point, we've been learning a few things up until this moment in this series. We've learned what a mole is. We've learned how to calculate moles from mass. We've learned how to calculate mass from moles. Now we are ready for what I call the heart of stoichiometry, and that is called the mole ratio. It's called the mole ratio. So let's take a few moments to learn what the mole ratio is. A mole ratio is simply the relationship that exists between substances in a balanced chemical equation. The ratio comes directly from the coefficients. The coefficients are the large numbers that are placed in front of the formulas in chemical equations. For example, here is a balanced chemical equation on the screen right now. If you are asked what is the mole ratio that exists between nitrogen and hydrogen, what you are simply to do is to extract the two of them. So you can see nitrogen on this part of the equation, and you can also see hydrogen on this part of the equation. The next thing to do would be to extract the coefficients. So what's the coefficient standing in front of nitrogen over here? Now you can see that there are no numbers standing in front of nitrogen. So that automatically leaves us with a number 1 as the coefficient for nitrogen. Why? Anything multiplied by 1 remains basically the same. And you can see hydrogen having a coefficient of 3 standing in front of it. So we have 1:3. This is the mole ratio that exists between nitrogen and hydrogen. What does this mean? The mole ratio simply means 1 mole of nitrogen reacts with 3 moles of hydrogen. That is what the mole ratio simply means. It simply tells you how many moles of a particular substance reacts with a particular number of moles of another substance, or produces a particular number of moles of another substance. Another example, if you're asked to find the mole ratio that exists between hydrogen and ammonia, now you can see the two of them. Hydrogen is over here, ammonia is over here. So let's extract their coefficients. For hydrogen, we have a 3 standing in front of it, and for ammonia, we have a 2 standing in front of it. That leaves us with the mole ratio of 3:2. What this simply means is 3 moles of hydrogen reacts to produce 2 moles of ammonia. So this basically is how you extract the mole ratios from chemical equations. Now that we know how to extract them, it is now imperative that we move to simple mole-to-mole calculations. Let's see how the mole ratio can be inserted in chemical equations and stoichiometry. So these are the easiest stoichiometry calculations, by the way, the mole-to-mole calculations. What happens over here is that you are given a number of moles and you are asked to find the number of moles for another particular substance. No mass is involved, No molar masses are involved. No complicated conversions, just mole ratios. So let's see if we can handle a question or two. But before that, there are a number of steps that you need to take before you can handle questions that involve mole to mole calculations. What are they? Well, most beginner stoichiometry questions follow this pattern. Step number one is find the mole ratio. Step number two, apply the ratio. Step number three, get the answer. That is all. So let's check out some examples and see if we can learn a thing or two. Example number one. Given this equation on the screen, here is the equation. They said how many moles of hydrogen are needed to react with 4 moles of nitrogen. How many moles of hydrogen are needed to react with 4 moles of nitrogen? So step number one, get the mole ratio. Step number one, the mole ratio. So how do we get the mole ratio? The first thing to do would be to get the point of reference. Now, from the equation, they said how many moles of hydrogen. So the first point of reference is hydrogen. Let's write that down. Hydrogen. And are needed to react with 4 moles of nitrogen. So we're talking about hydrogen and nitrogen. And from the equation, let's extract them now. Hydrogen is 3H2 and then nitrogen is N2. You can see how we have extracted them. And from the equation, you can see hydrogen has a coefficient of 3 standing in front of it, and nitrogen has a coefficient of 1 because there is nothing basically in front of nitrogen. So that leaves us with 1. So this is the mole ratio. What does the mole ratio mean? It means 3 moles of hydrogen, H2, reacts with 1 mole of nitrogen, N2. That's what the mole ratio simply means. Now the question says how many moles of hydrogen are needed to react with 4 moles of nitrogen. So step number two, how do we apply the mole ratio? So now that we have written the mole ratio over here, the next thing to do would be to put in the question, how many moles of hydrogen? So we'll say X moles of hydrogen, H2, will be needed to react with, from the question it says 4 moles of nitrogen. So we have 4 moles of nitrogen, N2. At this point, we simply cross multiply. This goes to multiply this and this goes to multiply this. So we have 1 multiplied by X is equal to 3 multiplied by 4. So this is basically X and this becomes 12 moles. So the answer to this question is 12 moles of hydrogen, H2, are needed to react with 4 moles of nitrogen, N2. So can you see how those steps were carried out? First of all, we got the mole ratio. Step number two, we applied the mole ratio. And then step number three, we found out our answer. Let's get to see another example so we can further broaden our understanding about this concept. Well, the next question on the screen says, given this equation, now we have this equation on the screen. They're asking how many moles of water are produced from 6 moles of hydrogen. Let's tackle the question. Step number one will be to get the mole ratio. So how do we get the mole ratio? Well, the first thing is to get our point of reference. The question says how many moles of water. So the first thing we're dealing with is water, H2O, and are produced from 6 moles of hydrogen. The next thing we're dealing with is hydrogen, H2. So let's get to see the equation and extract them. From the equation, H2O is 2H2O and hydrogen, H2, is 2H2. So the mole ratio that exists between them is basically 2:2. Now we can break this down and simplify it to become 1:1 because 2 can divide 2. 2 can divide 2. When the 2 cancel out, they leave us with 1:1. What this simply means is that 1 mole of H2O is produced. Why am I saying produced? Because you can see H2O is at the product side of the equation. So 1 mole of H2O is produced, or produced, yes, produced by 1 mole of hydrogen H2. So you can see how the mole ratio was written out. So step number 2 would be to apply the mole ratio. So how do we apply the mole ratio? Let's check out the question. The question says, how many moles of water are produced from 6 moles of hydrogen? So we have 1 mole of H2O produced from 1 mole of hydrogen. So they said, how many moles of water? So X moles of water, or H2O, will now be produced by 6 moles of hydrogen H2. Now make sure that when you're applying your mole ratio, the chemical elements are aligned with each other. So the place that I put H2O is also the place that I put the unknown moles of H2O. H2O is under H2O, and then for here hydrogen is under hydrogen, okay? Not mixing them up. So at this point I can cross multiply, and when I cross multiply I have X times 1 being equal to 6 times 1. So this leaves me with X, and this is 6 moles. So the answer to that question is 6 moles of water. 6 moles of water are produced from 6 moles of hydrogen. I'm sure you can see how the question was tackled step by step. If you're enjoying this video, I implore you to please like, share, and subscribe for amazing content coming your way every day of the week. The next question says, given this equation on the screen, we have one equation on the screen right now. How many moles of ammonia are produced from 9 moles of hydrogen? Well, step number 1, let's get the mole ratio. Step number 1, let's get the mole ratio. How do we get the mole ratio? Well, let's get our point of reference. How many moles of ammonia? Ammonia is NH3. That's the first thing we're focusing on. And are produced from 9 moles of hydrogen. Hydrogen is the next thing we're focusing on. So let's extract nitrogen, or hydrogen, I beg your pardon, and ammonia. From the equation, you can see ammonia is written as 2NH3 and hydrogen is written as 3H2. So what this simply means is that the mole ratio becomes 2:3. So writing this down in plain English, it means 2 moles of ammonia, which is NH3, is produced by 3 moles of hydrogen H2. You can see hydrogen on the reactant side and ammonia on the product side. So now that we've extracted the mole ratio, step number 2 would be to apply the mole ratio. So how do we apply the mole ratio? Well, let's get back to the question. How many moles of ammonia? So we'll come under here and write X moles of ammonia, NH3, will now be produced from 9 moles of nitrogen, since we do not know the number of moles of ammonia that will be produced by 9 moles of hydrogen. So at this point, we do the normal, we cross multiply, and when we cross multiply, this becomes X times 3 is equal to 9 times 2. X multiplied by 3 gives us 3x, and 9 multiplied by 2 gives us 18. So x basically is equal to 18 divided by 3, which leaves us with the number 6 moles. So the answer to that question is 6 moles of ammonia are produced from 9 moles of hydrogen. So this is the mole to mole calculation. You can see we didn't find the mass of anything, we didn't convert, we just use moles straightforwardly. Let's move on in this series. One more example on the screen. Given this equation on the screen, we have the equation on the screen right now. How many moles of oxygen are required to react with 8 moles of carbon monoxide? Step number 1, let's get the mole ratio. So where are we getting our mole ratio from? Well, the first thing we are dealing with is oxygen. How many moles of oxygen? So we have oxygen and carbon monoxide, CO. Carbon monoxide is written as CO, not CO2, okay? The next thing to do would be to extract them from the equation. You can see oxygen is written as O2 normal and carbon monoxide is written as 2CO. Let's extract the mole ratio therefore. Oxygen has a coefficient of 1 and carbon monoxide has a coefficient of 2. So the mole ratio is 1:2. So writing this in plain English, it means 1 mole of oxygen reacts with 2 moles of carbon monoxide, CO. Alright, so now that we've extracted the mole ratio, the next thing to do would be to apply it. Step number 2. The question says, how many moles of oxygen? So under this place where I wrote 1 mole of oxygen, I'll now write X moles of oxygen will react with 8 moles of carbon monoxide, CO. So let's cross multiply, and when I cross multiply, I have X times 2 being equal to 8 times 1. So basically this leaves me with 2x being equal to 8. X is now equal to 8 divided by 2, which is equal to 4 moles. So the answer to that question is 4 moles of oxygen are required to react with 8 moles of carbon monoxide. I'm sure you catch my drift and you're enjoying the hang of this question. One more example on the screen. The next example on the screen says, given this equation, you can see the equation on the screen, how many moles of magnesium oxide are produced from 10 moles of magnesium? Well, let's apply the steps. Step number 1, let's get the mole ratio. So how do we get the mole ratio? You know the drift. We're dealing with, from the question, they said how many moles of magnesium oxide. So we have MgO first, and said are produced from 10 moles of magnesium, Mg. So let's get the mole ratio. From the equation, we have MgO written as 2MgO, and magnesium was written as 2Mg. So the mole ratio becomes 2:2, and we can break this down or simplify it to become 1:1. So in simple English, this means 1 mole of magnesium oxide, MgO, is produced by 1 mole of magnesium. Now the question says, how many moles of magnesium oxide? So I'll write X moles of magnesium oxide will be produced by 10 moles of magnesium, Mg. So let's cross multiply at this point. Now if I cross multiply, I end up having 1 multiplied by x being equal to 1 times 10. So x is basically equal to 10 moles. So the answer to this question is 10 moles of magnesium oxide will be produced by 10 moles of magnesium. That's how the mole ratio can be applied to questions that involve the mole to mole calculation. So the summary of all we've been saying since the commencement of this video can be capped down to this. Mole ratios come directly from balanced equations. Mole ratios are obtained from the coefficients. The coefficients are very, very important in calculating or in obtaining the answer for mole to mole calculations. Mole to mole calculations only require the ratios, and then most beginner stoichiometry questions can be solved in one step. And lastly, always start with a balanced equation. You would notice that every question that we were given, the equation that we started out with was always balanced, because it's the balanced chemical equation that can give you the accurate mole ratio. With that being said, here are some practice exercises I'd like you to try out your hands on. We have this first section, extracting the mole ratios. Here's the question on the screen. Then we move on to another question, extract the mole ratios as well. Feel free to pause this video and write down the questions if you need to, and drop your answers in the comments, where I'd be waiting to respond to every one of them. Here's the next section. We have this on the screen. Go ahead and do what the question asks you to do. Another question, question number 4 on the screen. We have the fifth one on the screen. Enough questions for you to try out your hands on. And then section C, 1-step stoichiometry. Go ahead, pause the video if you need to, and write the question so you can handle it, and drop your answers in the comments. And then we have the challenge question finally. Go ahead and answer them. And then we have this number 9 questions for you to handle. So up next, we're going to be dealing with the mass to mass calculations in stoichiometry. I'd like you to please sit tight and anticipate that video. It's coming up shortly. In the meantime, my name remains David, and I'm an online chemistry tutor for high school kids. Stay blessed, and I'll see you in the next video.